Hey guys, this is Mr. Sheeling here for the Unit 4.3 notes, and this is going to be the last set of notes for the semester here, and this is going to cover activity series. Okay, so we've gone through how to balance equations, we've gone through how to identify equations, and now we've got to figure out, will you have an equation, or will you have, a reaction? And so this is what the activity series is all about. Okay, so before we get into it, just remember, I'm giving you guys the full notes. Make sure you check and grab the notes off the PDF. Whatever it has to be, print them off if you're able to print them. Write them in a notebook, whatever it has to be. Okay, before we get going here, just as a reminder. Okay, so the activity series. Activity series, for the most part, it's a or I'll just say that on the periodic table, there are elements that are more reactive than others. And I think for the most part, even where you're at now, you should know that to a certain extent. That there are things that react well, there are things that don't react so well. There are things that say, for instance, all the noble gases that really they're not terribly reactive. They, for one reason or another, they're relatively speaking, they're quite inert. But then you've got a whole bunch of other things that, you pretty much expose them to the air and they explode. One of those being would be like pure potassium, even sodium will, if you expose it, sodium more for water, but if you didn't know, you have to store pure potassium in mineral spirits, mineral oil. Because if oxygen bonds to it, and if the humidity is high enough, you will cause an explosion. And that's actually happened before. You should look it up. That's happened before in actually high schools. And that's why a lot of high schools really don't carry pure potassium anymore. One of the reasons. So anyway, so what these notes cover is what will react with another. And so anyway, let's just kind of take a look at this. So the activity series that's mentioned here is going to be found, for me, it's found on the back here. Okay, for you, it's just on the second page of the PDF, however you're using this. And we'll go through that in just a bit. But notice it's the reactivity of metals, from most reactive to least reactive. And we rank it from top to bottom. So most reactive at the top, least reactive at the bottom. So how do we use them? So for reactants, so if the single metallic element is above the metal cation, because remember the metals are the cations, currently in the compound, the reaction will occur. If, however, the single metallic element is below the metal cation currently in the compound, the reaction will not occur. So what are we talking about here? So what we're talking about is you're given, so you'll be given these problems. Okay, you'll be given out something like this. Realistically speaking, it'll look like this. So it'll be 2Al plus 3Pb NO32. So what that is that aluminum wants to react with lead nitrate, and the question is, will it react? And it's your job to figure that out. And for the answer for this one, well, because aluminum is above lead in the activity series, the reaction will occur. Well, okay, well, what does that mean exactly? Well, again, by going off what it says up here, so here is the thing that wants to react with this, okay? And we have to figure out if it will. So what we're going to do is we're going to compare aluminum with lead on the back side here. So here's our activity series. So we have the most reactive up here, and then all the way down here with gold, least reactive at the bottom. Okay, I'm going to draw a little arrow and that's how we read this guy: most reactive, least reactive. So we started off with aluminum, and we're trying to see if aluminum will more or less replace the lead. So we're going to look down our list here, and we're going to find aluminum. So we're going to keep our finger there, and then we're going to see if lead was above it, and it looks like lead wasn't above it. And we're going to keep on going down just to double check, and there's lead right there. So because aluminum is more reactive to lead, that aluminum is going to replace, the lead in a single cationic replacement reaction. Okay. Now, in a lot of cases, and what you'll have for homework is that, again, you're going to be given this, where you're asked, here's what wants to react, will it do it? And it's your job to figure out if it will or not. And if it does, then you've got to do the extra step, and then you've got to show me how it is that, it would replace, in this case, the aluminum would replace the lead, and then you have to balance out the equation. Okay. So, and then even sometimes I know that there's a couple problems I'll give you where I'm like, just explain what happened. And so right here, this would be good enough. Because aluminum is above lead on the activity series, the reaction will occur. So and then there's number 2. Okay, number 2 is obviously here, no reaction. So, but again, imagine if this wasn't here. So we've got tin here, we've got tin and cobalt sulfide. Okay. Ooh, let me double check, is that tin? Sometimes I get tin and another element mixed up, just to double check. Yeah, tin. Yeah. Sometimes I get that mixed up with antimony, however you pronounce it. So let's say, you're given this. And the question is, will the tin, left-handy, will the tin replace the cobalt here? That's the question. So we go look at our activity sheet. And we're going to find tin. Ooh boy. Tin is all the way down here. And then we're going to check above. Let's see, cobalt. Boom. Cobalt is above tin. And because cobalt is above tin, we would say that there's no reaction. Okay? And again, if I was to ask you for an explanation, you would say, because tin is below cobalt on the activity series, we won't have a reaction. Bada bing, bada boom. Easy enough. Okay, and then let's just look at this problem here, because this will be a problem given to you. You'll be given a problem that is stated almost as if it's fact. Calcium reacts with hydrofluoric acid to produce hydrogen gas and calcium fluoride. Well, it's your job to double check that that's actually what will happen. So you'll be asked to write all this out. Okay, so you would write out calcium reacts with hydrofluoric acid, which yields hydrogen gas, H2, remember that Hofbrinkel, plus calcium fluoride, CaF2. You'll be asked to write all this out, and then you've got to determine, will that happen? So let's see. If that will happen. Okay, so Ca and then calcium and hydrogen. Excuse me. Going to look on here. So we're going to find out, there's Ca. Well, and I know I didn't see hydrogen, but just to double check. Yeah, oh boy. Then all the way underneath lead, there's hydrogen. So because calcium is above hydrogen, 100% this will happen. And if I didn't already balance my equation, I would then take the time to then balance out my equation. And then again, if I were to ask you guys to explain, you'd say, because calcium is above hydrogen in the activity series, your boy's going to have a reaction. Okay, so easy enough. That's the activity series. It's more or less just double checking that something will occur. And just to go over real quick, this is something that I don't want to really skimp on because this was part of the last set of notes. Right here, classic example of where we would have a single cationic reaction. Over here, same thing. Simple single replacement cationic. Oh my goodness. Single cationic replacement reaction. Okay, that's what we have here, and that's what we have here. And ultimately, that's what the activity series is checking for. So that's the activity series. If you still have any questions for me, guys, make sure you ask me, email me, send me a note on Remind, whatever it has to be. Send me a comment on Google Classroom if you still have questions for me. So anyway, that's all I have for you. I will see you guys in the next video. I kind of blanked on what to say. Thanks. See you later.